To answer part A, there are only two forces acting on the man: the downward gravitational pull and the upward normal contact force which the floor of the elevator exerts on the man. The gravitational pull is of course fixed in magnitude. It's not going to change whether the elevator is going up, down, or whatever. So if the man is accelerating upwards, it must mean that the normal contact force is larger than the weight. The reason why the floor of the elevator pushes the man up harder than usual is because the elevator is trying to accelerate upward. If the man doesn't accelerate as fast as the elevator, what that means is the man is going to go crashing through the roof of the elevator. If the floor wants to maintain its molecular structure, it will have to push the man up with a force just nice so that the man will accelerate upward at the same rate as the elevator. Okay, so now the story is the elevator is moving down, but it is speeding up. So it's speeding up on the way down. What that means is the acceleration of the man is downward. Since the acceleration is downward, we are going to take the downward weight minus the upward normal contact force, and we are going to equate that to the mass times acceleration of the man. Rearrange the equation. You'll notice that the normal contact force is indeed smaller than the weight, and it turns out to be 444 Newton. In the next scenario, the elevator is moving downward, but is slowing down. So it's slowing down on the way down. Since it's slowing down, it must mean that the acceleration is in the opposite direction, which is up. So the acceleration is upward. Since the acceleration is upward, we are going to take the upward normal contact force minus the downward weight. Upward normal contact force minus the downward weight, and we are going to equate this to the man's mass times his acceleration. Rearrange the equation. You'll notice the normal contact force is larger than his weight. Put in the numbers, and it turns out to be 638 newtons. Just a note, this question illustrates the difference between the man's true weight and his apparent weight. The true weight, which is the gravitational pull, is always fixed. It doesn't change. The apparent weight, which is really the man's sensation of his own weight, is through the contact force between him and the lift's floor. As you can see, depending whether the lift is accelerating upward or downward, his sensation of his weight changes. When the acceleration is downward, he feels a bit lighter than usual, and if the acceleration is upward, he feels heavier than normal. Okay, that's it, and thank you for using XM Physics.